Hey, Algebra 1 students, here we are at the end of Chapter 3. We're going to be talking about weighted averages. So weighted averages refers to problems that literally are talking about weighted averages. Imagine being in a class and you take 3 tests. But your teacher, for some reason or another, decides that the first test was only 20% of your grade, and the second test will be maybe 30% of your grade, and that last test will be 50% of your grade. This is an exact situation that you could see in a weighted average situation. So what does that mean? That means that this test isn't really worth as much as this last test. So you really need to get this last test going on if you want to pass the test. So if you had to find the average of the grade, if you had to calculate your grade, it wouldn't be as simple as just adding them up and dividing by 3. So that's what we're going to talk about. Weighted average would be each particular test, in this case, having a different value or a different weight. Mixture problems often deal with the idea of mixing different liquids of different concentrations. So we're going to talk about that. So for instance, if I made my famous classic lemonade, which has 50% sugar in the mix, and then I made my famous lime juice, which is 75% sugar, I'm kidding by the way, in my mix, and I decided to put it together to make my fancy citrus punch, the question might be, what's the concentration, right? What's the concentration of sugar in the citrus punch? And let's make the citrus punch kind of a crazy color here. So what's the concentration of sugar in my punch? And that would relate not only to the percentages, but actually how much of each. So let's say I put 1 cup of lemonade and 2 cups of my limeade at these different concentrations. I'm obviously going to make 3 cups of my famous citrus punch. But what is the amount of sugar? What's the percentage of sugar in there? That's what a mixture problem will be like. And uniform motion problems for us are really going to relate to the idea of rate times time equals distance. All right, you've seen this before. Let me write it out again. Rate times time. Let's do that. Rate times time is equal to distance. And so that's what our uniform motion problems are going to be about. And I think you've seen all of that before. So let's get started. So here's a different type of mixture problem where we're not dealing with the concentration of different things, but in a way we kind of are because we're thinking about the price of different things. So let's see. So here we have assorted dried fruit is going to sell for $5.50 per pound. And then how many pounds of mixed nuts that's selling for $4.75 a pound should be mixed with 10 pounds of dried fruit to obtain a trail mix that sells for $4.95 per pound? I think you should read it again. Because part of these problems are really challenging. I'm just going to be honest with you. Part of the problem is that you need to make sure you know exactly what's going on. So one of the things that are really helpful is to organize the information in a chart, and I'll be expecting you to do that as you do the problem. So I'll start off with a chart as we look at the information we have. Okay, this looks like a bit much. Let's talk about what we have. We know that we're dealing with dried fruit. That's the first thing we were told about. We've got mixed nuts, and we have a trail mix that we're creating by mixing the two things together. So when we're dealing with most of these problems, you're going to have an equation across the top. In this one, it's going to be the amount in pounds times the cost per pound is going to equal the total cost. And oftentimes, if you're dealing with money, you're going to have this same exact equation up at the top of your problem. So let's see if we can put our information together to come up with an equation that's going to lead us to solving. So we've got dried fruit. We were told that the dried fruit sells for $5.50 per pound. So I'm going to put my $5.50 right here. The next bit of information that I'm given is that the nuts sell for $4.75 a pound. I'll put that there. And then we're told that we were asked to figure out how many pounds of mixed nuts. So that's the thing we're looking for. I'm going to put an X because we're looking for this amount. How many pounds of mixed nuts should be mixed with 10 pounds of dried fruit? 10 pounds of dried fruit. So that tells me the amount that I'm using. So I'm going to put the 10 pounds of dried fruit there to create a trail mix that sells for $4.95 a pound. So I'm going to put my $4.95 here. What we know is that when we create this mixture, right, we need to add enough dried fruit. Well, we're going to have 10 pounds of dried fruit. We need to add enough mixed nuts so we're going to wear down the price in a way. Does that kind of make sense? If we have this more expensive thing, we need to add the cheaper stuff so we can create a mix that we can sell for $4.95, which is a little bit more than the cheaper stuff, the mixed nuts, and significantly less than the dried fruit. All right, so I know that I'm going to have 10 pounds of trail mix plus X. Where am I getting this from? Well, I know that I'm going to create my trail mix by adding the dried fruit and the mixed nuts. So the amount of trail mix will be 10 plus X. And then what I know is that the total cost for the fruit that I add will be 10 times $5.50. Right? That'll be the total cost of the dry fruit. And the total cost of the mixed nuts will be $4.75 times X. And then the total cost for the trail mix will be $4.95 times 10 plus X. What I know is that whatever dried fruit I put in here, whatever the amount of money it costs me here, it should be equivalent to this amount here. Think about it. The amount of dried fruit that I put in plus the amount of trail mix and the cost has to end up equaling the total cost of whatever this big batch of trail mix is going to be that I want to sell for $4.95. So that's where I get my equation. My equation will be 10 times $5.50 plus $4.75 times X, which will equal $4.95 times 10 plus X. So again, this is the total cost of dried fruit plus the total cost of mixed nuts has to equal the total cost of the trail mix this big bag of trail mix that we're creating, excuse me. And so now it's a matter of solving. So 10 times, should have used a dot here because I don't want us to get confused with the X's, but 10 times $5.50 is going to be 55 plus $4.75 X, nothing to do with that just yet. Then I'm going to rock a distributive property here and get 49.5 plus $4.95 X. And I know this is worrisome dealing with decimals and stuff like that, but we can handle it. This isn't too bad. What we're going to do is isolate, choose one side for X's. I'm going to put my X terms over here and my constants over here. And so since I'm going to do that, this 55 stays, but this 475 goes. Pardon me, 475X goes. So I'm going to subtract it from both sides of my equation, and I'm left with 55 is equal to $49.50. And this over here will end up being plus 0.20x. Does that make sense? 4.95x minus 4.75 gives me 0.2. Yeah, 0.2x. And then I'm going to do a little bit of work. I'm going to subtract 49.5 from both sides. Sorry about that. So when I subtract that from both sides, I end up with 550 over here. It's like if I subtract 55 minus 49.5, I get $5.50 or 5.5. And then on this side of the equation, I have 0.20x. I'm going to solve it like I usually would. Let me give myself a little bit of room. Going to solve it like I usually would, which is to divide both sides by 0.2. So I get 5.5 divided by 0.2 is equal to x, or 0.20. When I simplify that, so sorry, babies. After doing that problem, I get that x is equal to 27.5. And so what does that mean? Go back to your chart and remember that x referred to the amount of nuts that we were going to add, the amount of mixed nuts. And so we're going to add 27.5 pounds of mixed nuts to bring down the cost so that we can end up selling the trail mix for $4.95. All right, that was a lot of work. Let's take a look at this next one. I think we might get 2 done and then we'll have to do a part 2 and maybe even a part 3 to this video. That's okay. We're going to do the best we can. So we're going to solve a mixture problem with percents. Chemistry experiment calls for 30% solution of copper sulfate. Kendra has 40 milliliters of 25% solution. How many milliliters of 60% solution should she add to obtain the required solution of 30%? All right, so here we have another problem, and what we're going to do is just take a look at the things that we have. We've got copper sulfate at 25%, copper sulfate at 60%, and copper sulfate at 30%. And these are copper sulfate. I should say these are copper sulfate solutions, right? So it's a mixture of copper sulfate and other stuff. So what we need to do is first calculate the amount of each type that we have. We are given that the chemistry experiment calls for 30% solution. So this is our goal solution. Kendra has 40 milliliters, that's an amount. She's got 40 milliliters of the 25% solution. How many milliliters of this 60% solution? We don't know. That's what we're looking for. How many milliliters of this 60% solution should we add to obtain a 30% solution? So we've got lower concentration. We're going to add high concentration to get a designated concentration of 30%. Well, okay, well, let me get out of that. So clearly the concentration of 25% copper sulfate would be 25%. So I'm going to write the decimal version of 25%, which is 0.25. Following along, I'm going to write 0.60 here and 0.30 here to represent the decimal version of those percentages. And the next thing I'm going to do is calculate the amount of actual copper sulfate within the mixture, because if I know I got 40 milliliters and I know 25% is copper sulfate, then 40 times that 25%, which is going to give me 10, right? Makes sense. 1/4 is copper sulfate, 25%, therefore 10 milliliters, right? Get it? Okay, good. So then I'm going to multiply each of these. So 0.6 times x. And what am I multiplying here? Well, this is going to be the sum of both of these, right? The amount of copper sulfate that I get at 30% is going to come as a way, because of Kendra and she having 25%, she's going to add the 60% in there. So however much of the 60% solution she adds is going to add to her 40 milliliter solution. Got me? To give me 40 milliliters plus X milliliters. So I know that this solution will, I can determine the amount of copper sulfate by taking the concentration 0.30 and multiplying that by 40 plus X. And so I know that whatever amount of copper sulfate I have from this mixture plus the amount of copper sulfate I have from this mixture has to equal the copper sulfate I have at the end. So we have a very similar equation. 40 times, let's use a dot, times 0.25 plus 0.6x is equal to 0.3 times 40 plus x. And now I'm just going to go through and do the thing I know how to do, which is to solve an equation. I need to get x by itself, but first let me simplify both sides of my equation. 40 times 0.25 is 10, as we discussed before. Then I get 0.6 there. I'm going to rock a distributive property over here. 3 times 4 is going to give me 12. But it's like 40 and 3, which is 0.3, which is going to end up being a positive 12. Use your calculator if that doesn't feel comfortable to you. Plus 0.3x. I'm going to join like terms together. I'm going to let my x terms be over here, my constants over here. With a little bit of math magic, I get that I'm going to subtract 0.3x on both sides. That goes away. I get 10 plus 0.3x is equal to 12. And now I'm going to subtract 10 from both sides. When I do that, I get 0.3x is equal to 2. Dividing both sides by 0.3, I'm going to get that x is ultimately equal to 6 and 2/3. So that is my X value. I'm going to add 6 and 2/3 milliliters of this 60% solution to get what I want, which is that 30% solution. So X is equal to 6 and 2/3 milliliters of the 60% copper sulfate solution. Let's take up the rest of this in another video.